Okay, in the last video we left off here with this graphic organizer about the important points on a projectile motion quadratic graph. Okay, and just as a little review real quickly, we've got all these ordered pairs, these XY ordered pairs. For the X, it is how many seconds or how much time has passed, and then the Y, the output is after that many seconds have passed, what is the height? The really critically important ones that you're asked about a lot are the y-intercept, which is the initial height, the vertex, which represents a maximum point that was reached, and then the zeros, specifically the positive zeros, for how long it took for it to reach back down to the ground. Okay, and I got cut off a little bit at the end, but I did want to show you that on my web page I have a link to that organizer. That is one of the pages if you wanted to print it and put it in your notebook or have it for reference without having to watch the whole video again. All right, so now we're going to look at a couple of different examples, okay? And these examples, I'm going to give you an X value, or I'm going to ask you specifically some information about that vertex point. These are typically, for most people, sort of the easier kinds of questions that we can ask. I do have a graph over here to the side that I will reference, but you don't really need it because we have a function this time that we're going to use. We're going to use this function. This gives us a model for the height after X seconds, the height in feet after X seconds. Okay, so from what height was the coin thrown? Okay, well, when the coin was thrown, 0 seconds had passed. So we would then plug in 0 for every X and say Y equals -16 times 0 squared plus 32 times 0 plus 6, okay? And again, that would be that point that is the y-intercept here, okay? There is a point at 0, 6, and so that we would say that the height that it was thrown from then is 6 feet, okay? That's how far up it was thrown from. All right, what is the height of the coin after 0.5 seconds? We're going to do essentially the same thing. Instead of 0, we're going to plug in 0.5. Y equals -16 times 0.5 squared plus 32, it's not cooperating, times 0.5 plus 6. So that just basically means there's some random point here somewhere, I don't know exactly where it is, but somewhere on this curve. Okay, now I'm going to go to the calculator for a little help with this. Okay, you can use any scientific calculator to do this with pretty easily. -16 times 0.5 squared plus 32 times 0.5 and then plus 6. Okay, and so we'll get that it was a height of 18 feet. Okay. All right, so now we're going to do a little bit of focus on that vertex point, that maximum point in this upside down parabola, okay? All right, and so we need to know, in the first two examples, I gave you an X value, I gave you a time, but I want to know what is this height here, but I don't know the time. But the one thing I know for sure is that that is the vertex, okay? So I'm going to do the opposite of B over 2A. In a previous video, we did some practice with this, with using this as a shortcut for finding the vertex. So I'm going to do the opposite of B, the opposite of 32, over 2 times -16, which is also -32. So I'm going to get that it will take 1 second for it to reach that vertex point. Okay, so now I have that point there. Okay, it is 1 comma something. All right, and then what is the maximum height? Well, that is the y value also at that vertex. So now that I know how long it'll take to get there, I'm just going to substitute that in for height. That in for X times 1 squared plus 32 times 1 plus 6. All right, I think I can do this without my calculator. -16 plus 32 is 16 plus 6 is 22 feet. Okay. All right, just for grins, let's check that on the calculator. -16 times 1 squared none of you would ever put this in the calculator, I'm sure. Plus 32 times 1 plus 6. All right, and that does in fact give us 22. Okay, all right, so that's some examples of types of problems where I either give you a time to plug in, I give you an input like an x value, and you just substitute it in to find y, or if that point happens to be at that maximum point, then you can use that shortcut negative b over 2a to find the x value at the vertex, and then you can plug that in to find the maximum height.